With that, I would like to invite Kim on stage for the next session. Welcome, Kim.
Thank you. Hello, good afternoon. Very glad to see everybody over here. So I'm Kim Kwok Chung, Senior Security Advisor at AWS. And I've also my co-presenter, Jessica Ang, right? We've been working on this item from concept to actual realization by using SageMaker ML to build cyber threat detection models, okay? And this has been a long journey for us and a very meaningful one in discovering, learning, invalidating our assumptions, and proving other things. But more importantly, for the audience today, we want to show you how you can accelerate your journey on using ML techniques itself to build cyber threat detection models itself. It is not a item that is for the faint-hearted, I would describe it that way, right? You need to have grit, you need to have persistence in order to venture down this. But do realize this, there is actually a vast amount of resources, vast amount of compute power to accelerate that journey for yourselves, for your organization, for your data scientists itself. So let's get into how the material today. We identified that many organizations actually have a huge amount of data sitting there. And they have spent enormous amounts of resources to build the SIEMs, data repositories, data lakes, but they're not extracting enough value from it. They're reliant on their data analysts, their security analysts, pulling out all information using various forms of visualization techniques. All are very valid itself. And when it comes down to actually building cyber threat detection models itself, or correlation rules if you're using some SIEMs, and it becomes actually limited by the analyst experience or the experience of the team. So how can we go with something that is more based on data to actually uncover those threat techniques, those attack patterns itself, right? Instead of being limited by your expertise, by your analysts, by your team. And during that journey, as we go through together during this specific illustration, is that you will discover that I didn't realize this specific type of feature or characteristic is actually important in identify, for example, what constitutes a malicious PDF document, which you'll see later. And more importantly, when we talk to customers, how have you started on this ML journey specifically for security itself? Many of them told us that they are actually bounded by their on-premise infrastructure. They took, on average, those that we polled, 2 to 3 days from the start of actually starting the training itself to getting a result of whether it is actually sufficiently accurate or poor, and what type of hyperparameters they have to go through was actually manually done. With SageMaker itself, SageMaker Autopilot specifically, you are actually able to accelerate your innovation by running 250 experiment trials in a day. So imagine this, you prep your data, you're going out for your lunch, and you hit the creation of the experiment, all right? You have a nice long lunch, maybe for 2 hours on a Friday afternoon. By the time you're back, you actually see your model actually being ready. That's the kind of power and acceleration and productivity that you can get compared to waiting 2 to 3 days later for, do I know whether those hyperparameter tunes outcomes are actually strong and robust enough? So we have actually designed a event-driven type of architecture that is able to stream information using Firehose Kinesis and also batch mode by uploading to S3 itself. But we developed this from the personas, 2 very key personas, the data scientist and also the security engineer. The data scientist builds, constructs the various forms of features that are actually required in order to do a ML prediction. So they're building that ML outcome. And that can be used in terms of like identifying C2, command and control characteristics, DGA, domain algorithm generated itself, like botnets. And all those models would be developed in collaboration with the security analyst and security engineer, right? So as you can see over here, the stages whereby the data scientist has actually collected all that pool of information provided by the security engineer or analyst, drops it into the S3 bucket itself. And once you've dropped into the bucket, you actually fire off an automatic triggering of notifications for the next stage of parsing. And this will start basically with a field level extraction. Field level extraction will be from, for example, your Windows proxy logs or Windows event logs. It pulls out the date, timestamps, event IDs, descriptions, source IP addresses, destination IP addresses, and so forth. Next, it will do feature extraction. Now, feature extraction is basically a computation of those fields that you have extracted. For example, how many times have I seen this specific event, authentication event specifically, to that host by this user ID in the past 15 minutes, 30 minutes, 60 minutes in the past day? Those are the features that will be used in doing the ML prediction. So you need to go through 2 stages of processing: field level extraction followed by feature extraction. And that can be done either by using Lambda or containers itself. So the output would then be provided to the security engineer. And this output is specifically referring actually to your SageMaker endpoint, whereby there's actually a trained model ready for them to use. You use an API gateway itself to interface those various versions of models that your data scientists actually collaborated with you to develop. And when you call that API gateway, you simply just call, this is my set of URLs, this is my document, this is my Windows event files, and that API gateway will then call the relevant threat technique models that have been developed to give you the answer of this event is malicious, benign, or suspicious. Okay? And we'll give you a demonstration of how that looks like later on. So we'll walk through 2 specific types of scenarios that we have developed. We have a couple other scenarios under the hood that we have been working on based on customer feedback, right? So these are some prime examples that we want to show you. Now, before you actually can start developing your data models, you need to have a pretty good diverse sets of data sets to work on for that specific problem you're addressing. And in this case, it's about URL threat assessment to identify command and control activities, or DGA. We usually start, basically, think of this problem of developing a data source in 3 tiers, like a cake. At the very bottom, the foundation would be based on public research data sets. Canadian Institute for Cybersecurity has fantastic repositories of the information. They have DNS data, they've got URL sets, and many others. That's actually a very strong foundation that you can build upon. Japan CERT has also published well over 4 years of data that you can use, right? And that's actually labeled data that you can start your data journey. On the next layer itself will be open source intelligence. You can rely on these types of information feeds to give you context of what's happening right now in the environment. Okay? Let me give you a reason why we need to do this open source intelligence layer specifically. If you were to use the data sets that were provided actually just on the ISCX URL 2016, we didn't have COVID then. Yeah, of course, right? When we created the models, we trained it, and we actually sent across those domains related to COVID phishing campaigns. We got very low accuracy. But once we added the latest information related to what's happening currently, the accuracy improved tremendously. All right? So you need current context. There's the basic characteristics that the public research data sets will give you, but you need current context, which is what the open source threat intelligence provides you. And finally, to make it work for your organization, you do need to add a retraining feedback loop, whereby you add in your domains, your whitelisted domains that your organization typically use. Look at your proxy logs. Those are fantastic sources to actually do the whitelist and also the blacklist. So with that methodology in place to actually get started in preparing and assembling the data sets, use AWS Data Brew to take a look at the general characteristics of your data. Things to look out for, we strongly recommend all of our customers and people working on this problem is look out for empty values, sparseness in your data sets, duplicates, and if you're doing a classification problem, make sure you've got the right labels there, right? On the part about balanced data, this is extremely crucial. You want to minimize, not eliminate, minimize bias in your data. So when we look specifically at the domain field itself, for the data sets that we have, we see an extreme skew towards GeoCities and AngelFire based on the data sets that we have collected. All right? And this represents unnecessary bias in the model that you would train. So you need to look out for these characteristics itself. Test and verify. Now, going back to this specific area of URL threat assessments, it was actually a research journey for us. We read many research papers. We read the material coming out from the Canadian Cybersecurity Institute. We read material from various universities itself. And we've then learned that how do you represent randomness in a domain? How do you represent that? And there are two specific characteristics I want to point out on entropy and character continuity rate. Those were commonly raised in a lot of research papers. But how do you translate that into code itself? So we've been working on this, and right now we have basically about 70 plus features that we have actually developed, right? Each one would be assessing based on the domain, the path, the parameters, and the query. And after we have done the extraction, you do the counts based on the number of tokens that are present, number of digits, number of special characters, and we throw it into the machine learning model, SageMaker specifically, and this is the outcome of the learning itself. Domain token count, the character continuity rate, and the entropy are very strong signals itself in predicting whether a given domain is suspicious or malicious itself, or in this case, benign. Okay? And you will see this consistently when you use SageMaker itself for classification problems itself. And here's the confusion matrix coming out from there, and it gives you a pretty good understanding in terms of the efficacy of your model. Moving from URL threat assessments to pick up command and control events, let's take a look at now how we apply that same methodology with respect to document threat assessment. In this case, specifically on malicious PDF. So these are the various sets of fields and information that you can extract from a PDF file, right? So for most of the people here who are security analysts and engineers, when you're examining a malicious document, you typically look out for JavaScript that's attempting to fire up a shell, PowerShell specifically, or command prompt, right? That was my assumption because having been working in this area, I thought, yeah, that would be enough to actually ascertain that whether a document is potentially malicious. But once we ran through our model, surprisingly, metadata size was actually a pretty strong determinant of whether a document is actually malicious. I didn't realize that itself. But if you dig into the specifics and details, why metadata size is quite important is that when we look at metadata of the document, there's actually quite a variety of sets of information. And we do see some injection of material inside the metadata, right? I didn't realize that. So that was my own learning experience. So like I said earlier, your analyst has their own experience, is bounded by what they have gone through a number of years and their exposure. But using data approach, you take away that limitation, you have your data sets, you prep it well. I'm not saying that your training data is going to be perfect, but it's going to be at least more or less representative. Well, when you have millions of records, that's what you will get. You actually have, for those organizations, actually have email threat scanning sensors, right? That is actually an enormously powerful repository for you to collect those documents. You know it's bad already, so it's already labeled for you. So start working on that. And that's actually a powerful information source that you can tap onto, okay? To start building this model for yourselves. And guess what? That is also highly representative of your environment, okay? So that's the journey itself of what we've taken. Now we're going to show you what's under the hood. All right, so I'll pass on to Jessica to show you what we have built so far. Jessica? Slowly.
Hey, thank you, Kim. Hi, I'm Jessica. So I'll be walking through the demonstration of what Kim had walked through earlier. So to get started, right, we'll start with the personas of the data scientists, how they do data preparation, how they actually train the model, followed by security analysts, how they actually use the trained model itself to use it to find out whether if a URL is malicious or not, right? So you start with data preparation from a data scientist perspective. So over here, you can see that right now we have uploaded the data into an S3 bucket, and that is actually data that will be used for the model training. So over here, we're using Data Brew to visualize the data itself and to find a few things. For example, is it duplicated? Is the data balanced? Is there like extra or additional labels? And if you look at the label, so below here, right, is all the features that's related to this data. You can notice that there are only two distinct values for the label, malicious and benign, because this is what we are interested in, right, when you talk about URL analysis. And now we want to focus into domain. So we need to look into the balanced data, right? So if you take a closer look at the two domains over here, GeoCities and Angel-Fires, you notice that they're a lot higher than the rest. GeoCities is 2%, Angel-Fire is 1%, where the rest is actually less than 1%. And these are actually the type of data that you want to correct. And you want to reduce the additional amount so that the data will be balanced and before you can use it for your training itself. So using Data Brew, you can see that it helps you to easily visualize the distribution of information easily. So once we had the data ready, right, we want to proceed to training the model. So on 21st September, right, we have announced that SageMaker Autopilot, powered by AutoGluon, can now run 8 times faster. And it also supports a wider range of algorithms such as GBM, CatBoost, XGBoost. And also you can use SageMaker Autopilot itself to run 250 trials to find out the best model. And all these are done automatically for you. So you just take a nap. The moment you wake up, you get the best optimal model. So we first started with creating the experiment. So first of all, let us just create the experiment name. Followed by, we will select the data that we had already prepared earlier. So this is the same S3 bucket that we had uploaded the data earlier. And the output itself, we also choose another S3 bucket where SageMaker Autopilot will store the model output to that particular S3 bucket. So if we scroll down, you saw this target. So we will select label. So this label is the prediction result. So remember earlier we talked about we are only interested in binary classification, malicious and benign. So this is the prediction result that we will expect to see from the label itself. And now we'll proceed to create the experiment, which will create an endpoint of the best optimal model. So over here, you can see that SageMaker Autopilot itself, right? Once you create an experiment, it actually runs quite a number of processes. Like for example, feature engineering, model tuning, and generate report for you. All these are done automatically by SageMaker Autopilot itself. So now that we have the best optimal model, so we want to see the accuracy of the model. So over here, you can see that that's a confusion matrix, which help you show you the kind of true positive and true negative, and really help you to see what is the accuracy of the particular model itself. And now we want to zoom into the feature a bit, right? So these are the feature that is relevant to the prediction. So when talking about prediction earlier, we see the label, right? Is malicious or benign. So these are the features that is relevant to the prediction outcome. And this is based on sharp value. So if you scroll down below, you can see this hyperparameters. Good thing about using SageMaker Autopilot is also that it will tune the hyperparameters automatically for you. So if you're going to do it yourself, right, you probably have to do multiple times to really get the right model. But for over here, you can just create an experiment and it will find out the best hyperparameter for you. So now that we had the endpoint, we had the best optimal model ready, so the security analyst can now then use it for their day-to-day work, such as finding malicious URL. So in the next slide, right, what you see is, from a security analyst perspective, how they can then use the endpoint to work on their daily work. So first of all, right, as a security analyst, we upload a file from so it contains a set of malicious URL that we got, and this set of URL that we have got is data that we are not used for the training itself. So they are new data. So we'll run it against the model that we had deployed earlier. So if you scroll down, you can see that these are all the results that is being displayed by the deployed model. Benign, malicious, and to the right, these are all the relevant features that is being pointed out by SageMaker Autopilot. So this allowed the security analyst to go back and do further investigation. So all the malicious data that we have, right, is stored in these services called AWS Security Hub. And over here, if we select one of it, for example, this is a PDF model, you're able to see that these are the results that's being written from the Security Hub. And this one is for the URL analysis. And this is actually also the model that we deployed earlier. So what we are trying to do now is to really show to you, right, from beside, after the scientists actually deployed the model, it's very easy for the security analyst to use it. And you can actually store it somewhere, or the malicious data somewhere. So if they want to, they can always go back and review it. So this demonstration shows how you can use SageMaker Autopilot to uncover threat techniques or pattern beyond correlation rules. And also how you can accelerate innovation by building solution on scalable cloud with broad set of Amazon SageMaker machine learning capabilities without being restricted by on-premises infrastructure. With that, I'll pass on to Kim to walk through the essential takeaway.
Thank you, Jessica. Now, there's one thing I'd like to highlight for everybody is that this really is just the outer layer, the UI, but behind the scenes is actually a rich set of API services fronted by an API gateway. Now, you don't have to use this UI. You can use your own SOAR, you can use your own SIEM, it can be from your own security analyst machine itself. Fire off the API call, of course with the right authentication being done, and you get back the results, right? So we're providing tremendous flexibility to our customers by actually leveraging APIs call, by leveraging Security Hub, because it's already got a standardized set of data fields and formats that you can reliably use and reference, okay? So here are some of the essential takeaways itself, right? Number one, a representative labeled data set is essential if you're going with a supervised learning problem you're trying to solve. Not all cybersecurity problems can be done this way. I want to be clear about that. But certain simple first-order form of classification problems can be done in this manner. Look internally within your organization. Your Windows events, your Windows proxy logs, your firewall proxy logs, VPN logs, and also, of course, don't forget your SIEM. You actually have a tremendous source of information there. How can you mine that data for classification problem solving using ML? The second point is that ML retraining is absolutely crucial because your organization environment changes from time to time. The threat environment changes much faster than you think it does. So retraining is important, and we are putting in mechanisms to monitor the efficacy of the trained ML model that you've deployed. Truly very important. And what you need to do is actually build a ML ops pipeline, just like DevSecOps, but an ML ops pipeline, right? A parallel correlation of that. And you'll go through the same rigor of actually coding, testing, training the model, retesting it, and once it has met your goals of performance, deploy it, push it out into your environment through a pipeline, with versioning, of course. And on point 3, SageMaker Autopilot really is the productivity game changer itself. Moving from 3 days waiting for the outcome to be ready to 250 experiments done within a single day or within a few hours itself. We have, when we first started on this itself, we were basically using Jupyter Notebooks doing the manual changes. And then when Autopilot came about, we started using it. We would get our results within a day. And most recently, in September, it was announced that we had the updates to Autopilot. It runs 8 times faster now. So that's the aggressiveness, because customers like yourselves are asking for that. We recognize that. We want to increase your productivity. We don't want you to wait, right? And the fourth point, and this really, really is the most important part. A multidisciplinary team is crucial in order for you to make this ML journey successful to identify cyber threats in your environment. You need a data scientist, you need cybersecurity experts itself, people who know how to code, right? And when we first started this, we have two other colleagues here, who actually, one of them, Noor, calling out there, and our data scientist, Yuan Shi. They were so important for us to make this work itself. I understand how to attack environment. Jessica knows how to break things apart. Noor knows how to build. And Yuan, she's a magical data scientist. You need that dynamics in the team to actually question each other, understand the data, put it into context, and build it correctly. So to get started on this ML journey itself, right, specifically for threat detection, look at building these capabilities and resources. It is not a one-man team doing it itself. It's a collective team sport. It really is a team sport, right, Jessica?
Yeah.
So it requires quite a fair bit of training and learning itself. This is not a level 200. This is a level 300, 400 type of endeavor. So get yourself trained, go through our skill building and certifications, understand how to build machine learning models, understand how to build data lakes itself with security controls in place. We'll now spend some time to actually take questions from the group itself. Happy to help you understand what we've built so far. Any questions? Yeah, C1, please. Can you speak up, or is the mic coming to you?
Yeah, sorry. So I just want to check, right? Does Amazon have its, or rather does AWS,
Yep.
does it have its own threat hunting models that are already in place? And whether or not just now the models that you showed, is there community kind of models that we can actually tap on that can not say replace data scientists, but it can help make their job easier in a sense?
Right, so out of the box, threat models from AWS. Okay, so what you were looking at just now, right, was actually processing non-AWS logs, okay? If you want to use AWS threat detection models, turn on guard duty. It's done, taken care of for you, okay? Now, we are working on actually preparing a blog itself, and we're going to open source this, okay? So if there's any party out there who's interested in partnership development, right, we're more than happy to have that conversation with you, right? We have this product is meant to be a starter pack itself to accelerate that build. We will open source the code that actually does the PDF parsing, URL parsing, Windows event parsing itself, all right? We want to democratize this information for everyone. Questions? I hope that answers your query. How many data scientists in the room? Don't be shy. Oh, I see one hand. How many security two. How many security engineers? How many security analysts? Okay, a few. All right. Look at each other, start talking to each other, work it out. I can assure you it is frustrating and addictive at the same time. Okay? Jessica, any more points?
So initially when we first started, we doesn't know about how important data preparation is. And the first model that I came out with, I was showing Kim that, it is by luck, like the same thing give me different results. So in the end, he actually told me to really break things into smaller part, and we really tried to play around with the data before it really start to work. So it does take a lot of people and the whole team and you need to have patience to get your model out.
Yeah. So
Yep.
what Jessica was describing was that what you saw the URL threat assessment just now. When we first started out, it was one mega large compilation of over 1.5 million records. Okay. We were getting about 75% accuracy. We were not happy with it. So when you have a problem that's too big, what do? You break it down into smaller parts. So we broke out the data into more smaller parts, looking at specific attack patterns, specifically things like DGA. And that's when things really changed. All right? We saw an increase to well over 95% accuracy for DGA itself. And if we're looking for more very specific ones on ransomware, we can actually potentially increase that too. All right? So, and that's the story that Jessica is also trying to share with you, right? Try once, you probably not get it right. Try again, experiment. It really is an experiment. Change one variable at a time. Use SageMaker to make that easy for you. It will really help you out in that. Okay? Any other last questions? We'll be around. Okay? So happy to take any other questions if you may have. All right? Thank you.